So, what if you could basically put scientific discovery on fast forward? Well, today we're going to look at how that's happening right now. We're diving into a single scientific paper that uncovers a whopping 34 new ways AI is being used in material science and chemistry. And what's absolutely wild is that all of these tools, they were built during one 24-hour hackathon. All right, so to get our bearings, we're going to use this. The paper calls it the research constellation. Think of it as our map for today. It shows us the 7 key areas where these new AI tools are making a huge impact, from dreaming up new materials from scratch all the way to running entire labs automatically. It shows how AI is getting woven into, well, every part of research. So our first stop on this tour is a really big one: designing materials. We're going to see how AI is taking this leap from just predicting properties of stuff that already exists to actually creating brand new materials designed for really specific, really complex jobs. I mean, this is a massive challenge in science, right? It can take years of just trial and error. But one of the projects from this hackathon shows how an agentic AI can step in and act like this brilliant, tireless research assistant, solving the whole problem in just a fraction of the time. Okay, so this diagram really shows you the magic of an AI agent. See, it's not just one single model. It's more like a manager that directs a whole team of specialized tools. It gets a simple prompt, and then it tells tool number 1, hey, go read the existing research. Then tool number 2 uses that knowledge to design a new molecule. And then, this is the really critical part, tool 3 acts as a reality check, basically asking, is this thing you just designed even chemically possible to make in a lab? It's a full automated discovery loop, all in one system. And here you can see that whole process in action. This timeline shows how methodical the agent is. It starts with a material we already know, and then it just makes these smart, small improvements. You can literally watch the band gap on the slide drop with every single step. It goes from 2.33 EV all the way down to a much more optimized 1.61 EV. This is exactly how a human scientist thinks, but it's compressing months of work into just moments. All right, let's move on, because this builds. It's not just about designing materials inside a computer. It's also about making the real lab, the physical lab, way easier to use. AI is basically creating simple, natural language interfaces for these incredibly complex scientific tools and simulations. You know how it used to be. Doing science often meant fighting with some ridiculously complicated software for months, maybe even years, just to learn how to use one machine. The new way? Well, it's becoming as easy as just talking to the machine. This tool, LangSim, is a perfect example. A researcher can just type in a request in plain English, something like, find me a copper-gold alloy that has this specific bulk modulus. The AI agent then just translates that into a super sophisticated simulation, runs it, and comes back with the answer. It completely gets rid of the whole programming barrier. And this isn't just for computer simulations. LL Micro SkyPilot does the exact same thing, but for actual physical hardware. It works like an AI co-pilot for a multi-million-dollar microscope. A scientist can just ask it to find the best settings for an experiment, and then tell it to run the scan. This just blows the doors open for who can use these powerful tools. Okay, the next big challenge that AI is taking on is just the insane volume of scientific data. Every single day, there's a flood of new papers and new results. So let's look at how AI helps not just manage this flood, but more importantly, how it pulls brand new discoveries out of it. And it starts right at the source. This tool, Yellowhammer, automates one of the most boring but most vital parts of doing research: writing everything down. A scientist can literally just snap a photo of their messy, handwritten lab notebook, and this AI agent turns it into a perfectly structured digital database entry. It saves so much time and prevents a ton of errors. But managing your own notes is just one piece of the puzzle. The real gold is hidden inside the millions of scientific papers that have already been published. So the big question is, how in the world do you connect all those dots scattered across decades of research to find the next major breakthrough? Well, this is where a tool like Active Science comes in. It's basically a super intelligent librarian. It reads thousands of papers on its own, it pulls out the key facts, like which material has which property, and then it builds this giant, interconnected knowledge graph. It's literally turning a library of messy articles into a structured brain of scientific knowledge that you can actually ask questions. So this leads to a really important question. I mean, it's one thing to pull text out of a paper, but can these AI models actually understand the complicated chemistry they're looking at? A project called ChemQA decided to put this to the test, essentially giving these models a chemistry exam. And the results are pretty fascinating. When the models only got text or only got an image of a molecule, they did okay. But when they got both together, the text and the visual, their ability to reason about the problem shot way up. It just confirms that for real, deep scientific understanding, context is everything. Just like people, these AIs get it so much better when they can see the full picture. So after this whirlwind tour through the research constellation, let's just step back for a second. What is the big picture here? What does all this actually mean for the future of science? So what's the major takeaway from all this? First, this speed of progress is just mind-blowing. This hackathon proves that AI is creating a whole new way to rapidly prototype scientific ideas. But, and this is a really big but, we are still in the very early days. The next big hurdle isn't just about building more cool tools, it's about making them tough, reliable, and ensuring that we can actually trust the discoveries they help us make. And this really leaves us with a powerful final thought. We are walking into a brand new era of scientific discovery. And it's an era that might be defined less by that lone genius having a eureka moment, and more by the amazing collaboration between a creative human mind and an artificial intelligence working together as a team. Hey, if you enjoyed this breakdown, make sure to subscribe to VibeDoc on YouTube to stay curious. Thanks for watching.